we're team number 8. Our second project for Mechanical Design 2 is design of a transmission. Our group is conformed by Miguel Verdia, Alex Rosales, and Camilo Trujillo. Now we're going to talk about the problem statement. They're giving us a transmission that should safely transmit 8.5 horsepower, and we should be able to reduce our speed from 720 RPM to 45 RPM. The velocity ratio is going to be 16. We should be able to design the system with a low precision application. The direction for the shafts are going to be basically the same. Our humidity level is going to be from 90 to 95%. We should be able to design the system with a low cost, but also taking into consideration they should be very efficient. Also, the system is going to be designed with a moderate shock. And now we're going to talk about some target applications.
Okay, when we started the design of our project, we've considered all these 4 sets of gears: worn, helical, bevel, and spur. However, this one, which would be a very good choice, it has a lack of efficiency, and it has a problem for parameters because the shafts are not in the same plane, and that was one of our requirements. So we scratched this type of gears because it will present problems for the designing of it. And for simplicity and for cost reduction, we also scratched the helical type. So we were only left with spur gears that are a logical choice, and one set of bevel gears in order to create the 90-degree angle between shafts, which was also one of the requirements. A power transmission design is basically, as we all know, since we're already Mechanical Design 2, is an application that's able to transmit power from one side to the other, reducing or increasing revolutions depending on the application. I'll give you 100 examples of those. We can see the ones in our cars. Every car has a transmission design, and it's basically, like I said, a machine that is able to transmit power from one side to the other.
Okay, this is the conceptual design. We came up with these 2 first sketches. In the first sketch, we used the principle of the bevels. We change our direction of the power transmitted. We use a set of bevels 1 to 4 and a set of gears of 1 to 4. Doing the calculations, we came up with a failure here in this pinion due to the high stresses created by this bevel over here. And we decided to add another set of gear in order to distribute the load. Here, as you guys can see here, we create another set of bevel using a ratio of 1 to 1 to 2, and it failed too. The final design, due to the higher stress created by this gear, we create another gear bigger than this one, and in that way we safely could transmit the power. And this is an example of our final design. Okay, this is the animation of our SolidWorks creation. Here is you guys can see the enclosure and how the velocity and the input is 16 times higher than the output. The setup here will appear slowly. Okay, so you guys can see the motion of the gears inside the enclosure. Okay. This is like basically a sketch of our Excel calculations. We calculate the actual stresses and the allowable stresses for every single set of gears. This is the given values from the Boston gears with the number of teeth, laminar pitch, and everything, etc. And we came out here with the factor safety of each set. During the reactions calculations, we use a program called MD Solids. Easily to use. We calculate the reactions at the end of the shaft, and we came up with this calculation in Excel in order to calculate the stresses of bending and shear stresses in the shaft. And if you say no, we can see here the factor of safety of the shaft. Okay, and the bearing selection, we did it by hand. We did the calculation by hand, and we select our bearings. In internet, we select different kind of bearings, Timken, SFK, and another one. So this is basically an example of what we did. Cost analysis, Camilo will talk about.
For the cost analysis, we basically we basically took all the parts that we needed for it to build the transmission. We come out with 5 shafts, 7 gears, and 12 bearings. We basically, once we did all our calculations and get all the numbers from the catalogs, we went online and we tried to find all the prices, being able to find a budget. Although we think it's a very competitive price for the system, but we know that it's a room for in order to improve the price. Since we only build in one, is actually a price that it could be improved. For the maintenance of the system, is basically, we did the calculations for our bearings based on 15,000 hours. So it means after 15,000 hours, you have to replace them. The oil that the most manufacturers recommend is Mobile HC 634, which it will keep its viscosity with a high under high temperature. We actually have to create a case since we're going to have a high humidity ratio. And now for the applications, here's Miguel.
Okay, here's an example, a couple pictures of some of the gearboxes. Here's an example that just like ours is 90 degrees and in the same plane. And we can see here a very common application for gearbox, which is a mining industry. And here's also a turbine. In conclusion, what we found out doing this project was that there was a lot of learning to do, of course, and there was a lot of mistakes that we did at the beginning. Even with our final design that was also able to produce results, we think we could improve it a lot if we had the same time constraint.